So today's topic is about angle of deviation produced by prism, plus 2 physics, chapter optics. So now we will see what is a prism. This is the basic structure of a prism, and we have a angle A, and this angle A is called the apex angle or angle of prism or refracting angle of prism. So this will be the shape of a prism you might have seen in the lab. Okay. Now this is the prism. Okay. First we must know the angle of incidence. So for that, first you draw a normal to this plane. Okay. And an incoming light is projected from P to this point Q. Now you measure the angle this is called angle of incidence. So angle of incidence, first you must draw this is the plane, you draw normal, the wave is projected from P to Q, so this angle is I1. That means if there is a normal, if the wave is projected this way, you should measure this angle. This is angle of incidence. Okay. Now we have angle of incidence as I1. The wave should have gone in this direction if there is no refraction, but the wave has bent like this and goes from Q to R. So the angle it has deviated from the original path is D1. Okay. Then it reaches R and it should have gone straight, but it has deviated from this point to this. Okay. And it goes in the direction RS. There is once again a refraction. Okay. Now first you consider this point. So the idea is the angle of deviation. Totally, if there is no prism, the wave should have gone like this, but it is going in this direction. So what is the total angle? It has been deviated. That we have to find out. So the wave light is coming from P to Q in a straight line. So you have angle of incidence I1. Okay. Now if we draw this line and this line, this D1 and R1 is nothing but I1, because so this is the line, this point, this is angle of incidence I1, and this angle is D1 plus R1. Okay, this is the normal, actually this is the normal. So this is D1 plus R1. If you consider this point R, you have this angle as D2 and this angle as R2. So it goes like this. This is the point R. Okay. Now the angle between this point and this point is I2. That means D2 plus I2 is D2 plus R2 is equal to I2. Okay. Now if you carefully consider this, from this equation I1 is equal to D1 plus R1, which implies D1 is equal to I1 minus R1. From this I2 is equal to D2 plus R2 implies D2 is equal to I2 minus R2. Okay, that means the wave should have gone like this, but it has deviated. So this is there, you have one deviation, and then it goes like this. Once again it is deviated. So this angle from this normal, this is D2. Basically this angle is D2 and this is R2. So this since this is D2, this is also D2. So total deviation is D1 plus D2. Okay, that's what is given here. The total deviation is D1 plus D2. So once again I repeat. So the wave from P straightly goes up to Q and then it is deviated. You should have gone this, so it has been deviated by an angle D1. That is first. And then it goes like this. You should have gone straight, but it has been deviated. This angle from this point to this point is D2. From this point to this point is R2. Okay, that means this R2 is equal to this R2. This D2 is equal to this D2. That is I2 is equal to R2 plus D2. So the total deviation is what? D1 plus D2. That's what is written here. But from this equation we know D1 is I1 minus R1, I1 minus R1, plus from this equation we know D2 is I2 minus R2. So D2 is I2 minus R2. So I1 plus I2 you combine, you take minus sign out, so it becomes R1 plus R2. Now what is R1 plus R2? It is nothing but the angle A, this angle. We call it as apex angle or angle of the prism, which is A. Now how to find this A value? Okay, now come to the quadrilateral. A, Q, N, R. A, Q, N, R, A. If you complete that, you see a quadrilateral. So you all know that this angle A and Q, N, R, the angle, this angle N. If you add, you should get 180 degree. That is the angle A, this angle, plus this bottom angle Q, N, R is 180. Similarly, if you consider Q and R triangle, Q, N, R, this triangle if you consider, if you add all these three angles, you should get 180 degree. So angle R1 plus angle R2 and the angle here QNR, that is this angle N, you should get 180. So angle R1 plus angle R2 plus QNR is equal to 180. The right hand side of this equation is 180, the right hand side of this equation is 180. Okay, that means left hand side should be equal. That means angle A plus QNR should be equal to angle R1 plus angle R2 plus Q1R. Now Q1R gets cancelled. That means angle A is equal to angle R1 plus angle R2. Therefore, R1 plus R2, that is angle R1 plus R2 is equal to angle A, which is nothing but the apex angle. So why we are not making use of this R1 and R2? Because R1 and R2 is the angle inside the prism. Practically, it is not possible to measure R1 and R2. Whereas this angle of incidence and the angle of refraction outside the prism, all measurements can be done. If you carefully look at this equation, I1 you can measure because it is outside the prism. I2 also you can measure because it is outside the prism. Then minus angle, you know the apex angle of the prism. This angle, that also can be measured easily. So if you know these three values, I1 plus I2 minus A, you can always find the total deviation of the incoming wave through the prism. So it enters from P point it reaches Q, then it moves to R and then to S. So the total deviation is found out using this formula D is equal to I1 plus I2 minus A, where A is the apex angle or this angle and this is angle of incidence, and I1 and I2 you know. Okay, with these three things you can always find the deviation. So one more point, the angle of deviation depends on totally 4 points. If you see angle of incidence, so this angle, it depends on I from this equation. Angle of the prism is A. You can have a prism with the angle 30 degree, or you can have 60 degree or 45 degree, it can be anything. So it depends on the angle also. Angle of the prism, material of the prism. The prism is made up of what? Glass, mica or any other material. Okay. So like that, it depends on the material of the prism. And finally, wavelength of the light. It also depends upon the wavelength, lambda. For example, sunlight, you know, it has all the colors, all the wavelength. So if you see the visual spectrum, human visual spectrum, it ranges from 330 nanometers to roughly around 720 nanometers wavelength. So roughly yellow will be maximum. So VIBGR, VIBGYOR, and R and above you have infrared. So the deviation The angle of deviation depends upon the individual colors also. You have a infinite lambda between 330 and 720 nanometer itself. So it depends upon the wavelengths. So these 4 points you have to remember. So the angle of deviation depends on these four, that is angle of incidence, angle of prism, material of the prism, and wavelength of the light. So this is how you have to derive for angle of deviation produced by the prism. Thank you for your attention. Thank you. Nandri.